Hi, this talk is the part one for hypothesis testing. Outline: hypothesis-driven research, hypothesis testing framework, sample size and power. So hypothesis-driven research is pretty big, especially in NIH-funded research. So basically what it means is every clinical study starts with a testable hypothesis. For example, we think vitamin C reduces the prostate cancer risk, or lead exposure damages children's brain development, etc. And statistic hypothesis testing is part of the scientific methods. So basically, you start with a hypothesis, and then you formulate statistic hypothesis, and then you design your study, and you collect your data, and you analyze the data, then perform hypothesis testing, then go back to answer your original research question. So that's kind of the whole process of scientific research. And right now, clinical research is dominated by hypothesis-driven research. So that's very important. So that's why hypothesis testing as part of the statistical theory become also very important because it's so integrated into the general scientific research framework. So what is hypothesis testing? Hypothesis testing is a statistical inference tool, and hypothesis testing is for testing clinical theories. Hypothesis testing is a process of multiple steps. So this just give you some general descriptions about hypothesis testing. Okay, and hypothesis testing ends up with a decision making to be in favor of a null hypothesis and its opposite, the alternative hypothesis, based on data. Of course, as well as the statistical hypothesis test method. Okay. So let's just in general talk about hypothesis testing framework. So step one, formulate the null hypothesis H0, which is usually no effect, and the alternative hypothesis H1 usually say there is an effect. Okay. And two, identify the appropriate statistical test statistic for testing the hypothesis. And three, specify the level of significance alpha. And four, compute the test statistic using the sample data. And five, compute the p-value based on the test statistic value and the null distribution. And six, reject H0 if p is less than alpha, otherwise accept H0. The statistical power for the hypothesis testing process is the conditional probability that given H1 is true, we reject H0, and it equal to 1 minus the beta, or the probability of rejecting a false null hypothesis. All right. So this is a very general description about hypothesis testing framework. And of course, you can see there's some terminologies mentioned here, like null hypothesis and alternative hypothesis, and the level of significance, test statistics, and the null distribution. Okay, so the test statistic has this feature that if we assume the null hypothesis is true, then the test statistic usually will follow a probability distribution that's free of any unknown parameters. So we will be able to compute critical values or p-values from that null distribution. And also, every hypothesis test is done at a certain level of significance. So we do assign a certain level of significance. It's kind of at what degree we want to make our inference. Okay, so we have seen that hypothesis testing end up with a dichotomous decision. And of course, the true status also has either the null hypothesis is we are in favor of the null hypothesis or in favor of the alternative hypothesis. And so that's why hypothesis testing can usually lead to two types of error. So on the right-hand side, you can see a 2x2 table. So given the true status of null hypothesis and the alternative hypothesis, and then the action for the decision, reject the null and accept the null. So in two occasions, you make mistakes. One is called a type 1 error. Basically, the null hypothesis is true, but you reject it. Okay, and there's a type 2 error. Basically, the null hypothesis is false, but you accepted it. Okay, and the power is 1 minus beta. All right, so just remember this. Every hypothesis test will have these two types of errors. And so there's a very important concept related to hypothesis testing, which is statistical power. And so what is statistical power? It's not political power or electrical power or firepower of a weapon or anything. It is statistical power. What that means, okay, why that's important? Because when we design studies, we really need to know so how many subjects we need to recruit into our study. So that's called the sample size, and the sample size determined in relation to power. Okay, so here's an example of the sample size and the power in the famous Women's Health Initiative clinical trial. Okay, so here's a statement. In comparison, the design assumption for the DM component of the WHI lead to an assumed 14% lower intervention versus control breast cancer incidence, and a projected power of 86% for breast cancer alone based on a sample size of 48,000 and an average 9-year follow-up period. Okay, so from this statement, you can see some concept about the sample size and the projected power of 86%, and the effect size of 14% lower incidence rate, etc. So it gives you an idea about what a sample size and power statement would look like. So statistical power is a probability. So we talk about 80% power, 90% power, etc. The statistical power is the probability that we will be able to find an effect if it exists. And the statistical power is a conditional probability. That is, if the effect exists, given the effect exists, we can detect an effect. Okay, so statistical power is truth power. And why is statistical power important? Okay, so basically, if you are one of the decision makers who oversees millions of dollars in research funding, okay, so are you going to really give someone multi-million dollars to do a study without any estimation of the likelihood that you are going to be able to find an effect, even if the effect exists? Okay, so in a certain way, every clinical study is a gamble. Okay, so if you're already so sure about the result, you don't need to do a study. Okay, so when you start a study, you mean you're uncertain about the outcome. So you're going to gamble. So to gamble with millions of dollars of federal funds, so you need some assurance. You need some kind of estimation of statistical power. So statistical power is part of the assurance that we are not throwing away money with good chance of winning. And factors affecting statistical power. So statistical power is not like a single factor. It relates to multiple things. For example, sample size, the alpha level or level of significance, effect size, or directionality. So when sample size goes up, the power goes up. When the alpha level goes up, the power goes up. When the effect size goes up, the power goes up. And if you do a one-sided test versus two-sided test, the power goes up. Okay, and the relationship between all these multiple factors can be really complicated and can be informative. Okay. And so here's the summary on statistical power. Statistical power is the conditional probability of rejecting a false null hypothesis. Statistical power is an estimate of the likelihood of detecting an existing effect when designing a clinical study. And statistical power is a part of the hypothesis testing framework for clinical research. And statistical power is affected by multiple factors, including sample size, alpha level, effect size, and directionality. Thanks for watching.